Can I start? So we're going to discuss today conditional probability. Write it. Slightly difficult than the other question, whatever you have done up to this. So conditional probability. All right. Right. The definition. Let us write it. The conditional probability of E given that F has occurred is given by P of E condition to F equal to P of E intersection F divided by P of F. Okay. Provided P of F is not equal to 0. Provided P of F not equal to 0. Okay. This is a basic definition. I'm going to explain and we are going to apply this in the questions. Right? Can I start? Here, while finding in the last class, we are trying to find the probability of a certain event. But now, with the event, that is okay, the event will be there. We will also have a condition to obtain the probability of a particular event. Okay, we will also have a given condition. So based on this condition, we have to find the probability. So I just give an example, which is not very similar to this, but anyway, if suppose it rains, for example, I won't go to school. Okay, or I won't go to college. So this is the condition. If it rains, this is the condition. Then I won't go to school. That is the statement. Now this condition here will be given in some other way. Just I am trying to mean what is conditional probability. So whatever the condition will be given, that condition will be taking as F. Okay, it is given that, or this portion is only the if. Okay, that means the condition. So if it rains, suppose that is the condition which we are going to consider as F, then I won't go to school. This statement we are going to take as E. So here, just to make you understand, I give an example. It's not like that actually here, but anyway, so based on the condition or depending on the condition, we have to get certain probability. Now, to see that how it could be done, so what you have to do is they are individual events. So E and F will be individual events. What you're going to do is to find the probability of E condition to F. Look at that. What is how to read it? Probability of E condition to F is probability of E intersection F, which we have discussed in the last class. That is common for all of them. So probability of E intersection F divided by probability of F. So this just you need to find out. And here P of F should not be 0. Probability of the event F should not be 0, because you know if it is 0, then it will become not defined. Yes or no? So I just do 2 or 3 examples. I think it will be okay after this. Is it done? Can I go to the next slide? Okay, some people have joined just now, just wait. So we are going to find conditional probability. When I give some examples or question, when you do some questions, I think it will be clear. Right now, this is the definition to find conditional probability of an event E subject to the condition F, or depending on the condition F. How to find it? The intersection of probability of the intersection of E and F, both the events, divided by probability of the F, the condition. Okay. So let us write some examples on this. Okay. Question 1. I'm just taking very easy question at first. Question number 1. If P of A, just a minute, yeah, if P of A equal to, suppose 0.8, P of B equal to, suppose 0.5, comma, P of B condition to A. Now B is the even, but based on the condition A is 0.4, suppose is 0.4, then find number 1 P of A intersection B, find number 2 P of A condition to B. Just to understand all the terms, this example I have taken. Number 3 P of A union B. Okay, so this is a very simple definition to understand the terms what actually P of A, P of B and B condition A means here. Now P of A is probability of getting the event A, P of B is probability of getting the event B. Now here probability of B is given subject to the condition A, and you are asked to find all these 3 terms. Now when I start the answer, I just take the help of P of B condition to A. So this is given as 0.4, right? Just now in the previous slide I explained P of E condition to F how much? Probability of getting E condition to F is, say, P of E intersection F. It is probability of getting E and F by P of F. Now if this condition is used here, so on the left hand side, you just see it will be what? P of B intersection A, same, just E and F to be replaced by B and A, by P of F. So what is the second event here? Subject to the condition A, yes, this is equal to 0.4. So if you now find it, P of B intersection A, I think you have some idea about these sets. P of B intersection A and P of A intersection B is having the same meaning or the same. Now this is our aim, question number 1. You see, this is our aim. Now P of A is given 0.8 and this is 0.4. Now if you take this P of A intersection B equal to, if you take this 0.8 there, so it will be 0.8 into 0. How much? 32. So this is the first example or the first answer. Okay. Now let me go to the second one. I think it is okay. Yes. Now if I try the second example, as I told you, this is just to understand the basic of what is conditional probability. Now number 2, if I start, this is given P of A condition to B. Try using the previous formula. What is that? P of A intersection B divided by P of B. And you can see while finding this, I'm just trying the second one now. So while trying to find this, P of A intersection B is already, we got it here. How much? 0.32. P of B is also given in the question. How much? 0.5. And just to convert it into, fractional form, it will be 32 by 50. Okay. And now if you cancel by 2, okay, it will be 16 by 25. Is it okay? Correct? Okay. The third one now. Okay. The third one, which we did not discuss before, but it's not that difficult. So I'm going to do it now. The third one here, number 3. Here we are asked to find P of A union B. Or we can say we are asked to find P of A or B. Now to find P of A or B, there is a very simple formula. which I did not do it before. So I'm going to explain this formula now. Getting P of A or B is P of A plus probability of getting A plus probability of getting B minus probability of getting both. So it means that the probability of A union B, probability of A, union refers to OR, yes or no? So probability of A or B is equal to, how this formula works, is probability of A plus probability of B minus probability of A and B intersection. Now, while trying to find this, you see, this is, we are asked P of A union B, which I have written given a formula. Now P of A, just to put it, P of A is 0.8, P of B is 0.5, intersection is 0.32, so it will be 1 point, correct, minus 0.32, just you subtract whatever the answer, okay, that is the required probability. Is it okay? Done? Alright. So these are the basic terms, but this type of questions, come very less in numbers. We are given mostly application based questions. We are mostly given application based questions. So I am going to do a question on the application of this. Can I go to the next slide? Okay. So question number 2, application, huh? Right. Number 2. A coin is tossed thrice or 3 times. A coin is tossed 3 times, where 2 events are given. Event E, suppose head on the third dice, head on the third dice. This type of questions we need to practice more. Okay, not the first one is a direct definition based question, but here application based. Okay, F heads on the first 2. Heads on the first 2 tosses, on the first 2 tosses. Okay. So the question is, find probability of E condition to F. As I told just now, application based questions are only important mostly here. Even in your textbook, you can see all questions which are application based are only given. Okay, so this example just to understand the terms I just explained that. Now we are going to start this question. Okay, now here in the last class also we did this similar to this question of the sample space. So it's given that a coin is tossed how many times? 3 times. So if I find the sample space means what? The collection of all the outcomes. Now you notice a coin is tossed 1 time, the coin is again tossed, the coin is tossed again. So the outcomes will be H. Do you remember how many outcomes I said? 8. How? Because a coin has 2 outcomes. What are those? Head and tail. Head and tail. A coin has 2 outcomes. Head and tail. How many times tossed? So 2 cube. Total how many? 8. And how it works? H. Okay, try. We did this in the last class. So H, comma, H, HTH. Then HT. Can I write also HHT? Yes. So next HTT. Keep saying. Can I have some more with H? Can I have some more with H? No. So it is 4 only. Now we should start with T. TTT. TTH. THT. And then THH. So these are the outcomes that I can understand. There are 8 outcomes we have. So these are 8 outcomes. Now let us find out E in the event E, which outcomes are there. What they said, heads on the third dice. The event E refers to the outcomes where the head comes in the third place. That means if I highlight, which all I need to take, you check it once. Heads on the where? Third dice. I think I should take this. Also this. Can I take this? No, because the head is not on the third one. I think I can take this, or also I can take this. Are these correct? So in these four, heads are appearing in the third dice. So let us write it. So how many we got it? H, H, H. Because head is there in the third. H, T, H. Head is also there in the third. And T, T, H. Head is also there in the third. And T, H, H. So these are the events where I got head, in the where? Third place. Okay, third dice. Now coming to the event F. What F says? Heads on the first two dice. On the first two dice, or on the first two tosses, head must be there. That means first and second both are head. So let us write down what are those. Can I write this? Yes. Can I also write this? Do I have some more? No. First two only head. So these two events outcomes only we can list down. So H, H, H. All right. H, H, T. Is it okay? Right. Now, as you know, what is the question? Find the probability of E condition to F. Now, if you see in the first definition today I gave you, now we must have the probability of the intersection E and F, and then individual probability F, right? Now, let us first of all find out what is the intersection of P, E and F. So, E intersection F, what does it mean? Intersection means what? The common elements which are there in both. So, intersection means those who are not of maths background. So you understand that intersection, that symbol refers to the common elements. So common element means which are there in both. Where? In E and F. E and F, E and F. So in these two, we have to find out the common elements, the elements which are there in both. Okay. Now let's try. Which element is there in both? H, H, H. Do I have more? HHC is here but not there. These all are there but not in this. So I can understand that only HHHR is the only outcome in A intersection F. Okay. Now let me complete the answer here. If I now try to get the answer for the probability, so what is the aim now? We should find probability of E intersection F. Okay. E intersection F. How many outcomes we have? Only one. Only one. Out of total how many outcomes? 8. Total 8 outcomes. So it will be 1 by 8. As you also know, since it is probability of E condition to F, we should have denominator what? P probability of F. So we must have the denominator P of F. So let us find out probability of getting F. In F, how many outcomes? 2. 2 by total, as you know, total there are 8 outcomes, because the total outcome always we take from the possible outcome sample space. So this is ready. Therefore, now come to the question. This is the question. Find P of E condition to F. Therefore, probability of E condition to F. What is that? P of E intersection F by P of F. Just you put it. E intersection F is how much? 1 by 8. And this is also again 2 by, so 8 get cancelled. What is the answer? 1 by 2. Okay, 1 by 2. Right. I just give another question that you'll try yourself at home later. Okay, is it done? Yeah. So I'm going to write down a question that you'll try. Okay, I can do it, but I think you got the point. Just to understand the the common outcomes and get the probability, and whatever the condition is given, condition is F, so that's F, you need to take it. So the next question which I am going to take it, even it is more application based than this, here actually it is given only, you have to find PE condition to F. Sometimes that line is not clear. So with the explanation of the question, I'm just going to tell you that which one is E, which one is F, and then you will try at home. Right, number 3. A black and A red dice are rolled. A red dice are rolled. Okay. Done. Question is number 1. Find a conditional probability of obtaining a sum greater than 9, a sum greater than 9, comma, given that, so one question we will do, given that the black die resulted, resulted in a 5. If required, I am explaining, you will let me know, you can understand these or not. Okay. So there were, I have some more questions similar to that, but I think with one it will be okay. So number, all right. Now you see, the question is find the probability that, try to understand, find the probability of obtaining a sum greater than 9. This is the question. Find the conditional probability of obtaining a sum greater than 9, given that, this is what I said few minutes back, this is the condition. If, okay, so condition. Now, the given that, since given that is the condition, with the given that, compared to the definition today which we did, given that which event? F, okay. So, the given that, whatever is there, that is the condition. With this, whatever the event mentioned, that is always F. So, the condition is always F. So, this is your F. Could you understand what I am saying? With the given then, whatever is there, that is your event F. That means, which one is E? Obtaining a sum greater than 9. So, this is your E. Could you get it? Yes or no? Alright. Now, so what do you have to find out? That means you have to find the conditional probability of obtaining a sum greater than 9, given that the black die resulted in a 5, means E condition to F we need to find out. So don't write, just to try to understand. We need to find out probability of E condition to F. And formula is known to you, P of E intersection F by P of F. But to get all this, you must have an idea about the intersection of E condition, E and F. So what it should be the probability, and this P of F, and just we put it there. Now, if I start this question here, first, try to understand total how many outcomes are possible. Because like the previous question, you see here sample space, there were 8 outcomes, so we had to write in the denominator 1 by 8. Yes or no? So in a similar note, we must know how many outcomes are there. S, any idea how many outcomes? Total, how many outcomes possible? 36. Did you get some idea about this? How? Because 2 dice are rolled. Alright, we are not listing all the outcomes because it takes time. 2 dice are rolled, so die 1 and die 2, second dice. Now when they are rolled, so these numbers are there anyway, we know that. Yes or no? Now when these dice are rolled, it might give you 1, it might also give you 1. Then it might give you 1, it might give you 2, 1, 3, 1, up to which number can come? 1, 6. Then again it starts from 2, 1, 2, 2 till 2, 6. So like that, 3, 1, 2, 3, 6, 4, 1, 2, 5, 1, 2, and finally 6, 1, 2. That means, as you rightly said, the total number of outcomes possible here is how many? 36. So we can write n of s instead of, see, in the last question it was, there are only 8, so I could list them. Alright. Yeah, also it helped me to get E and F. But since 36 outcomes are there, I preferred not writing all the outcomes because you understand there are 36 outcomes. But this is not P of S. This is not probability. It is just the number of outcomes in the sample space, total outcomes. All right. Now E. What is E? E, obtaining a sum greater than 9. Greater than 9. I give you an example. You got an outcome like 1 and 6. If you add it, how much? 7. Is it greater than 9? So we cannot take such outcomes. We have to take the outcomes where the sum is greater than what? 9. So with 1 it will not be possible, because with 1 6 only I got 7. So 1 5 1 4 will be less. With 2 6 also if I try, sum will be how much? 8. So with 2 also it will not possible. With 3 even I try, how much? 3 plus 6 9. It is just 9, but they are asking greater than 9. So what is the first possibility? 4 4 6. Can I write 4 5? No, because 4 5 is 9, not 6. Sorry, not greater than 9. So the very first outcome, yes, you got the idea. So let's continue. The very first outcome where the sum comes to be greater than 9 is 4 6. Try. So that means 4 6 only the very first outcome starts. So with 4 5 3 5 all these will not work. Say the next one. With 5. Can I write 5 4? No, it will be just 9. 5 5 5. Can I write 5 5? Because 5 plus 5 is 10, greater than 9. Can I also write 5 6? Okay. With 6. 6, no, I think we can do 6 4, because 6 plus 3 is 9, exactly 9. They're asking more than 9. 6 4 6 6 5, then 6 6, and we don't have 6 7. That means this is the last one. All right. Anything left? 6 4 6, yeah, done. Now coming to F. Coming to F, what they said, you see, given that is the condition as I told you, the black die resulted in a 5. Which one is black? The first one. So this is the black and this is the red one. So the black die resulted in a 5. That means here which number should come? First number is 5. They are not mentioning anything about the other one. They said only the black die must give you 5. So it is 5. Say first one is 5. So all possible. 5 1 5 2 5 3 5 5 what? 4 5 5 and 5 6. Since they're talking about the black die 5, that means the first outcome is only 5. Rest all we don't need only. I think it is okay? Yes. Now, what is the question? Find the conditional probability of getting E subject to F. That means your aim is P, E condition to F. So for that, you now rest of the things are similar. E intersection F. Common elements. Which all? 5 4 not there. 5 5 and 5 6. These are the common elements. So we have common elements intersection. Those who do not have idea, it is the common element in both. Common element in both. So this is 5 5 and 5 6. Now probability of E intersection F. Just a minute. Probability of E intersection F. How many elements are there in this? 2 out of. Total how many elements are possible? 36. So this is ready. P of what also needed? P of F. P of F is required. So P of F. F. How many outcomes are there? 6 out of 36. Now can you get the answer? So therefore, P of E intersection F equal to P of, therefore P E condition to F. Just a minute. Therefore P E condition to F. That is the question. It's just to find the probability of this. So P of E intersection F divided by, please put the value right now. So it is P of E intersection F is 2 by 36. This one is 6 by 36. 36 get cancelled. Even 2 by 6 is 1 by. So like this. This is what the conditional probability, as I said, it is there in page number 401. Right. Now one thing, you don't get confused in exams. This E intersection F, as I am showing it right now, just a minute. Yeah. as I'm showing with intersection, sometimes this intersection part they give with no symbol, like that. In your book also it is given like, so you don't get confused for what is that. It is nothing but the intersection only. So when it is mentioned PEF, you just understand it is the intersection part. Is it okay? Done? Alright. Let's go to the final topic of probability. Is it over? Yeah. So, last topic of probability. I'm trying to cover one question on this. This is slightly difficult. Okay? So, Bayes theory. Bayes theorem. As I am writing all the entire definition, if E1, E2, so these are even. The way I am taking E and F, so here I am just writing E1, E2, E3, etc. up to N. If these are N non-empty events, non-empty event means they must have some outcomes, okay, which constitute events which constitute a partition of partition of sample space S. Then and A is any event of non-zero probability then probability of EI condition to A is equal to probability of EI multiplied by probability of A condition to EI. This is conditional probability, but terms are slightly different. So it will be I equal to 1 to N. Oh, sorry, it is I is there, so let me take it J here. J equal to 1 to N P of EJ multiplied by P of AEJ. Alright. So this is what the Bayes theorem, slightly different and difficult. Try to understand. Now here you can see it is given that which constitute a partition of sample space S. Try to understand what does it mean first. Although we don't need all the definitions, but at least you must have some idea what is that. These are some events. These are some non-empty events. Now it is said they make together a partition of sample space. Partition of sample space means when E1, E2, E3, all the events up to what? En, all the events, the union is taken. That means together they are seen, all the outcomes, then it gives all the outcomes of the sample space. So this is first one. Understood what I'm saying? Partition in the sense when their union is taken, all the, see, just I gave an example in the previous one. So E was this, F was this. If I take the union, will I get S? No. Because here it has how many? 1, 2, 3, 4, 5. But here also 6. Total how many will be? Maximum 12. But how many are there? 30. So their union is not S. So they are not, going to form a partition. So partition means their union must be what? The sample space. Secondly, if you take E1, intersection E2, it must be phi. Phi means no element in that. So pairwise, it's not that only E1, E2, you can take E1 intersection E3, so and so on. Every time it should be what? That means any two events if taken, and their intersection is considered. Supposing E3, E4, their intersection, E2, E9, all these intersection pairwise, they must give how much? Phi. So in that case, they are called partition. All right. So one thing is good in here that whenever you get a question of Bayes theorem, they will be always forming a partition. You don't have to worry about they are forming a partition or not. Questions are given in such a way they are already forming a partition, right? So that means, I repeat again before I started Bayes theorem, partition in the sense all the events when their union is considered, it gives what? The sample space. Then pairwise disjoint. Disjoint means pairwise they don't have any common element. For example, U1 intersection E2, E2 intersection E9, whatever. Two events if taken, every time they will give you phi. That means they don't have any what? Common elements. Is it okay? Alright. So let's start. Achha, now what you have to find out of all those events, any one event will be given. The way we got it here, E condition to F. So only one event will be given, and subject to the condition of something else. Here it was F. So subject to the condition A is any other event for which or based on which or subject to which or condition to which you have to find a probability of E. And this formula, how it works, I'm giving an example. You'll understand in a better way. Okay. So let's try one example. Can I? Okay. So let us start a very first question of Bayes theorem. I'll be doing two questions, but you will try this topic. I think this is number 4 today. Right. A bag contains, I have to write the question, no other option, because those who will see the videos later, they must know what is the question. So a bag contains 4 red and 4 black balls. 4 red and 4 black balls. Comma. Another bag contains 2 red and 6 black balls, 2 red and 6 black balls. Full stop. Right? Now, one of the two bags is selected. One of the two bags is selected at random. Selected at random. And a ball is drawn from the bag. And a ball is drawn from the bag. Drawn from the bag, which is found to be, supposing, red, which is found to be red. Full stop. Find the probability that the ball was drawn from the first bag. Probability that the ball was drawn from the first bag. So this type of questions are also there in your textbook. You go through, find the probability that the ball was drawn from the first bag. Because there are how many bags? 2 bags. Find the probability that the ball was drawn from the, so I just read out once again. A bag contains 4 red and 4 black balls. Another bag, another bag, another bag contains, another bag contains, okay, another bag contains 2 red and 6 black balls. So there are two bags. Now one of the 2 bags is selected at random, and a ball is drawn from the bag which is found to be red. Done? Question is, find the probability that the ball was drawn from the first bag. Okay. I just give a diagrammatic representation. I think it will be better to understand if I draw diagrams. Can I start? Okay. There are 2 bags as you have seen. So supposing this is bag 1, okay. Supposing this is the bag 2, okay. Supposing this is the bag 2. Now bag 1, bag 2. Now in bag 1, how many red balls? Red balls? Okay. So here there are 4 red balls and 4 black balls. In this second bag, red how many? Red 2 and black 6. Now, without looking into the bags, look at the question here. Sorry, just a minute. Yeah. Without looking into the bag, one bag of the 2 bags is selected at random. So not checked which one. Just, take it like this without looking into the bag. So one bag is taken at random, and then a ball is drawn from the bag which is found to be red. Try to understand this line. Now, as I told you, without looking into the bag, then a ball is drawn. A ball is taken out from the bag, and the ball is found to be red. Would you understand? The ball which is drawn without looking to the bags, the ball is found to be what? Red. Okay? Would you understand the second line? Nobody has looked at the the bags and taking out one ball. Okay? So the ball that came out from the bag is a red. Not sure from which bag. Now the question is, find the probability that the ball was drawn from the first bag. The question is, what is the probability that the ball which has come out, red ball, it was from which bag? Bag 1. Okay. Now, to do this question, how many bags were there? 2. Please try to understand. There are 2 bags. The bag 1 we will be taking as E1. Bag 2 we will be taking as E2. Is it clear? Okay. Last questions while doing here F, just a minute here. F is the what? The condition. So it was the condition F that the black die resulted in a 5 was the condition. Now here the condition is, just a minute, where the condition is when taken out the ball, that ball is found to be what? Which color? Red. So here what we will take this E1, E2, E1 is the bag 1, E2 is selecting the bag 2. Now that A will take, event A will take which one? The red ball, because the ball came out was a, just a minute. So this A, actually here A is like F. A is like F, okay, the condition. Now actually it's not condition here, but anyway it's condition to F. The ball which was drawn, was a red ball. Yes or no? Done. Now the question you see, find the conditional probability that, or find the probability that the ball was drawn from the first bag. Find the probability that the ball, which ball? The red color ball. It was from which bag? First bag. What is the first bag I considered? This question. This is the question. Is it okay? If the same question comes, find the probability that the ball was drawn from second bag, then what will you do? E2. Okay. Now, how this formula works, that I'm going to explain after some time, but you got it now? Now, what you have to do? Okay, right. Let answer the question. Let E1 equal to the first bag. You can make your line shorter because it's a MCQ based paper, but I am bound to do all the steps, only then you can understand. E1, which one? The bag 1, E2. Which bag? The bag 2. Now, if I try to find P of E1 and if I try to find P of E2, what does it mean? P of E1 means how many bags? P of E1 means bag 1. How many bag 1 is there? 1 bag. Total how many bags are there? So P of E1 is 1 by 2. Actually, P of E1 means bag 1. There is only 1 bag 1. Out of how many bags? P of E2, second bag. How many bags are there? No, total how many bags? Second bag means bag. So their individual probability is 1 by 2. And the A, so which I showed in the diagrammatic representation, what is A? Getting the red ball. So A will take the red ball or getting the event of getting the red ball. I am writing in short. Done. Now here some terms we need to find out, which is P of, try to understand, AE1. We also need to find out P of AE2. And then, as I said here in the example, what you have to find out? P of E1 condition to A. Why? The red ball is from bag 1. Okay. So our aim is to get P of, say our aim is to get P of E1 condition to A. Now, before I explain these terms, let me write how this formula works. I repeat again, your aim is to get P of E1 condition to A. That means getting the red ball from bag 1. Now to get this, the Bayes theorem says, please look at that board. To get this from bag 1, it works like that. P of E1 to be multiplied by P of AE1. What is that P of AE1? I am going to let you know. So if it is P of E2, then what do you have to do? P of E2, A condition to E2. Now numerator and denominator again you have to write the same thing. P of E1 multiplied by P of AE1. But AE1 means A condition to E1. But here the other bag should also be mentioned in denominator. What is that? P of, because denominator is always the total, yes or no? So P of E2 multiplied by P of AE2. Okay. If there were one more bag, P of E3 multiplied by P of, and so on. Okay. But now we have only 2 bags. Alright. Now, which terms you don't have? We already have P of E1. We can put it. We already have P of E2. We can put it. But you don't have P of AE1. Now, what this P of AE1 means? Red bag that, sorry. A refers to what? Red ball. AE1 means red balls that were there in bag. Are you getting my point? Red balls that were in bag E1. So, in bag E1, that means bag 1, how many red balls were there? 4 out of 8. Write this. So, here we had 4 out of 8. Is it okay? Try to write A of E2. What is that? Red balls that were there in bag 2. How many it was? Just me check it. So, red ball there were how many? 2 in bag 2. Bag 2 how many balls we had? So, what is that? 2 by 8. Now, what you could understand, it's not, don't try to get here again, what? P of A intersection E. Are you getting my point? That you don't try to get this, conditional probability exactly here. So here it means, this terms actually means, as I said just now, the red balls that were there in bag 1. The red balls that were there in bag 2. And in bag 1, as you have discussed, in bag 1 there were 4 red balls out of 8. In bag 2, 2 red balls out of 8. Is that okay? So we just put it here now. And 4 by 8 means it will be 1 by 2. 2 by 8 means 1 by. Now, see, look at the symbolic difference. They are actually same. Red ball that were there in bag 1, but now from bag 1, the red ball is drawn. Getting it? So, Now just put it. I won't do the entire calculation. P of E1, how much? P of E1, how much? 1 by 2. While taking E1 and E2, A does not appear. That means it's all about getting, say, it's all about getting, but the selecting the bags multiplied by P of A E1, how much? 1 by 2. Is it correct? P of E1, again 1 by 2, multiplied by P of A E1, 1 by 2. But since the denominator is the total probability always, so P of A E2 also to be taken, 1 by 2, to be multiplied by P of A2, how much? 1 by, please complete the calculation, tell me how much you get it. And that is how the Bayes theorem works. 2 by final. Okay. So as he said, this calculation will be finally, it will be 1 by 4. It will be 1 by 4. This will also be 1 by 4 plus 1 by 8. And finally, after doing the steps, the answer comes to be 2 by 3. Done? Can you try? So you go through the questions that is there in your module, page number 401. So it's there also in page number 402. You'll understand now the examples you go through. Few examples are there of Bayes theorem. Alright. If there are doubts, you please let me know. Okay. So with this, the probability I am completing. The Bayes theorem and the conditional probability was the last topic. Now I am going to start and complete the module, last module tomorrow. Okay. Done. So with this, our syllabus will be completed. Okay. Okay then. Thank you.